Hello and greetings to our panels. We are Team LuckyNet from University Technology Kamarul. Welcome to our online presentation about our project, which is Intelligent Bed Management System. In short form is IBMS. In this team, we are consist of 4 members, which is myself, Nazeyra binti Jamaluddin, Nurazmina binti Kamarul Azim, Izzah Jasmin binti Zahari, and Nurul Syafiqah binti Mutapha Kamal. Before we go into more further details about the project, I will explain why we choose this project. Because of the changing patient loads and requests designed after sometimes assigning bed to the patient in the hospital recurred some problem. The allocation of hospital beds is limited, as the demand for beds come from 2 types of patients who are previously booked elective patients and who arrive randomly in an emergency room. So, many elective patients may result in exceeding the ability of one day, which may theoretically necessitate the overflowing of certain emergency requests that should be made as soon as possible. The problem of inpatient bed allocation for the patients because of the unscheduled emergency department admission from a significant number of unplanned admission to the hospital that arise randomly each day, which emergent needs highly uncertain lengths of stay of patients and the dependency on the schedule of the operating theatre. We have created a solution for the bed allocation in the hospital. Introducing to you the right bed system. There are 4 main features for this system, which is bed tracker, bed light, bed selector, and bed on the voice. The first features of this system is bed tracker. These features use data analytics to track the trend of the patient illness and suitable beds that meet the requirements. So the next features of the system is bed light, which is come from the sensor of the light to detect the availability of a bed in a ward or room of each department. Bed light also will determine whether the bed is available or not, and it also automatically recording and update the number of availability bed and then precise location of each bed within the building or ward. So the third features in this system is bed selector, which is the function is to determine a suitable bed for a patient. So there is 3 types of bed in this system, which is red zone, yellow zone, and green zone. It is divided by how critical the patient are. And then there are several selection of a bed that the hospital staff can choose according to the body posture of the patient. And the last features of this system is bed on the voice. For these features, the staff will make a voice note to make an audio clip to record the patient disease. The system will analyze the voice and the disease that have been described by the staff and show the available bed that's suitable for the patient.
Here is the activity diagram for the system.
There will be hospital staff and system view. Firstly, the hospital staff must log in. After the hospital staff log in, the system will validate the information. If the information is valid, it will proceed to record by bed on the voice. But if it is invalid, the hospital staff need to log in back. Okay, if the validation is successful, it will record by bed on the voice, and then the system will analyze the disease of the patient. And then the hospital staff can view recommended bed after analyzing disease by the system. In this part, there will be 2 options, which are the first one, it will show or request or ask for request for the bed selector. After that, the system will display the different type of bed. After display, it will show either you confirm the bed and then we'll proceed to the next step. But the second option, after view the recommended bed, you can also directly confirm the bed. After you have confirmed the bed, it will show a record number of availability bed by the system. And then the staff can view, which is by looking the bed like either it is green color or red color. And then the staff can view available bed per level. After that, the staff can view available bed per ward or room. And then there will be two option, which is the first one, either available or unavailable bed. Then it will proceed to the next step, which is view bed tracker. So in view bed tracker, the system will track the patient's disease and suitable bed. After that, the hospital staff can view the list of the patient after the bed tracker has been done. After that, the hospital staff can log out after all the process have been done successfully.
Now, I will explain more on the architecture diagram. Number 1, staff record an audio clip describing the patient illness or disease on the smartphone that is uploaded to the data lake. Create a data lake with Amazon S3 raw data, Amazon S3 processed data, and Amazon S3 Glacier. Number 2, show the availability of a bed on a monitor and update the state of IoT light bulb. Red light means the bed in the room or ward are occupied. Number 3, Edge Amazon Free RTOS send data to AWS IoT Greengrass, providing protection from intermittent connectivity. Number 4, AWS IoT Greengrass streams enables ingestion from edge devices to Amazon Kinesis data streams. AWS IoT Core and AWS IoT Device Management manage the cameras and events. Number 5, use AWS Glue to build the data catalog and to create the ETL jobs for data processing. Number 6, build visualizations of reports and dashboards using AWS QuickSight with AWS Athena and Amazon Redshift. Number 7, Lambda function initiates a transcription job converting the audio to the transcript using Amazon Transcribe. The job is monitored by Amazon CloudWatch. Number 8, other Lambda function is in charge of passing the raw text of the transcript obtained from the audio file through Amazon Comprehend Medical. Amazon Comprehend Medical helps extract medical entities. Number 9, the entities are then being stored in a DynamoDB table that can be used for analytics. Amazon Redshift reads and loads data from multiple data files stored. Number 10, derive real-time insights with Amazon Kinesis Data Analytics and notify users via Amazon SNS. Empower users with insights delivered via Amazon API Gateway.
So this is the prototype for our system. To enter the system, the staff have to assign in their identification number and password. After that, they will redirect to the latest health news page. If there is a patient that they want to allocate the bed, the staff can choose the BOV, which is stand for bed on the voice. The staff have to enter the patient ID and hold to record their voice. The system will analyze the disease. After that, the system will display the patient ID and the recommended bed with the level and the ward number. If the staff agree, they can choose the confirm button, or they can choose change button, so they will redirect to the bed selector page. So the bed selector will display type of the bed and the available number for each bed. The staff can choose the desired bed and fill up the patient information. When the staff choose the bed light at the navigation bar, they will redirect to view the available bed per level. If they click the level, they can view the available bed per ward or room. And the system also can display the available and unavailable bed per room. The red color stands for occupied or unavailable bed, and the green color stands for available bed. The staff can click on the occupied bed and view or update the patient information. Next, the bed tracker page is where the system displays the trend of the disease and the bed use. This will use the analytics to track the trend. If the staff want to view or search the patient, they can click the patient list. The system will display the list of patients. If the staff cannot find the patient name, they can search the patient name or their ID. The staff also can view and update the patient information. And after that, the staff can log out from the system.